Fine. One next topic is routing. Your router. Before that, we'll discuss L3 device, that is router or switch. What will be happen in routing table? Whichever basically router will work in layer 3. In layer 3, what it will be work in IP addresses. Apart from that, routing protocols will work. In that routing protocols will elect the best path based on the routing table. And whichever they are selecting the best path, electing the best path, based on that path, they will send the information. For example, here you have like multiple path. This is our router. And likewise, you have path. It's your destination. So this is your first path, and this is a second path. And if you have a third path also, like that, in this path, router R1 and R2. In this, these all are the routers are the path, whichever the source and it's a destination. Your destination in between router will elect the best path based on the routing tables. Based on the routing table, it will be elect the best path, first path and second path. In between, you can assume this one is a first path and this one is a second path, this one is a third path. If first path, it will be send information to this path. If this path is goes down, then it will be send the second path. Second path elected as a, it will be moved to the first path and the send the information. If this path also is goes down, then we have a different path. So routing table dynamically, they will elect the best path. Based on that path, they will send the information whichever we require. So here forwarding of packets from one network to another network, choosing the best path from the routing table. See, every router L3 devices will maintain the routing table. So router will work two or more than that networks. Okay, router will work. Yesterday we discussed it like if this is a different network and this one the different network and this one is the different network and this one is a different network. We'll assign for every interface as a different network. So router will work between a networks. Router will work between a networks. That networks will at available in routing table. So based on the routing table, it will be choose the best path, whichever I have mentioned. Then chosen that first path, it will be send the information to that path. Routing makes possible for two or more different networks to communicate with each other. Understood? So with the help of routing only, will communicate. Routing makes possible for two or more different networks to communicate with each other. So example here you have like, wait a second. So this is your LAN network and one more LAN network at different location, and they are connected with one router. So this is a LAN network. End users are connected. Hosts are connected. Hosts are connected. NDPCs, you can assume them. These are the host end users. So basically, what will happen? So definitely we'll use here different network. For example, it's a 12.1.1.1/24, and this one you can assume 11.1.1.1/24. This is a different network and this one is a different network. So routing makes possible for two or more different networks to communicate with each other. With the help of routing only it is possible. With the help of router only it is possible. In routing, router maintains routing table. Understood?
Yes, sir.
Fine. Routing table consists of only the best routes for every destination. So as I mentioned, here we have the multiple path. 1, 2, and this is our first and second and third. 3 paths we have. So router will maintain whichever the best path, and whichever best path, that only it will be maintained. Who with whom for every destination. So as I mentioned here, this is our source and this one is our destination. So our source and this is our destination. It means source means it's a like India location, and this one is a, you can assume this is a US location. We have a two branches. In India, one branch, and US we have another branch. So in between we have multiple ISPs. We are connected through ISP only. In between, multiple ISPs are there. So in between the path, it will be select whichever the best path. Then router will store that path only. Then the packets forward through that path only. Whichever routing table consists of only the best routes for every destination. Whichever routes are there, whichever best routes, based on that route only it will be sent the information. So basically here we have a different types of routing. These all are the based on the dynamically it will be elect the best path. It will be dynamically it will be elect the best path. But if you know how many types of routing protocols we have, types of routing. So here we have mainly three types of routing. Whichever the router will maintain the routing table based on our decision, based on whichever we are giving the commands, based on that only router will select the best path. So statically we are configuring and dynamic defaultly we are configuring and dynamically. So first one is static and default and dynamic. I'll give you the brief introduction about static here. So three types of routing table. Three types of routings we have here. First one is static. Guys, if you have any questions, ask me in between also. So static routing. It is configured manually by the administrator. We should have to configure manually. And mandatory need for a destination network IP address. Network destination network ID. What does it mean? I'll explain. And for every destination, routing has to be done manually. Yes. Used for small organization. It is not for big organization, and it is used the AD value that is 1. Okay, fine. First, mandatory need for a destination ID. So as I mentioned here, in top of that, this is a source IP address and destination IP address. So whenever we are configuring the static routing, in between, we plan to configure static routing, we should have to know the destination. Whichever the destination IP address is there, then only we can configure the we, static routing. Static routing, if we don't know the destination IP address, we cannot configure it. If you know the destination IP address, then only we can configure it. Even though we should have to know next interface also, this interface, this interface, this interface IP address. This interface IP address, this interface IP address, and this interface IP address. So the disadvantage is here, like if you don't know the between destination IP addresses, between hope IP addresses, next hope IP addresses, in between next hope IP addresses. So if you know the destination IP address also, so it will be not work. So each and every network we should have to know in between. If we have only one path, one in between one path, this is one router only in between. If you can assume this is one R1 and R3, this one R3 and R2, in between only one router, then easily we can configure it. Easily we can configure it. If you don't know this interface, if you know the destination IP address also, it won't work. We should have to know each and every interface's IP addresses. Then only it will be work. For every destination, routing has to be done manually. That is what. Every destination routing has to be done manually. We should have to done. It is for small organization for okay. If you have only this kind of organization, one or two branches in between. This is your branch land location and this is your land location within organization and within a building and within a campus network. It is good. If you have a large organization, it won't work. And AD value, it will be used one. What about the AD value? What about the AD value means with the help of administrative distance value only, we the routers will elect the best path. For example, on top of it, so here we have a three path, first path and second path and third path. So here you are using RIP, here you are using EIGRP, and here you are using OSPF. For timing, here you can assume like RIP, leave it, OSPF. Here you are using RIP, and top of one you are using like, sorry, no, this one is static. Okay, fine. Now good. It's static. Statically we configure static. Set static one, static routing and EIGRP and RIP. So RIP uses the AD value 120 and EIGRP uses the value 90 and static one is 1. Statically we are configuring, that is AD value is 1. So let's assume here, first of all, router will having how it will be elect the best path. Just hold 1 second, please. Yeah, sorry for that. See, first of all, how the router will elect the best path. There we have four types, four methods. First, it will be check whichever the longest prefix. First one is longest prefix. Then it will be move to the AD value. Then it will be moved to the metric. Then it will be moved to the ECMP. First, what is longest prefix? So this here we have the prefix like this prefix like /30 and /24. What does it mean? The value is here, top of one. First one is 192.168.10.0/30. And this one is that value is 192.168.10.0/24. And the value down is 192.168.10.0 slash like 8, like 16 you can assume. So in between, whichever that, sorry, better we'll take it as a 192.168.10.0.25. Okay. So in between, whichever having the longest prefix, here you can assume same prefixes we have. So whichever having the longest prefix, so it will be elected as the best path. It won't see metric, it won't see AD value, it won't see nothing. Metric also, it won't see metric, AD value, ECMP. First, it will be elected based on the longest prefix. In between, in this prefixes, longest prefix is 30. So it will be elect the 30 path is best one. Then it will be moved to the AD value. If longest prefix match, if longest prefix is tie, it means here we are using 30 also, here also 30, and here also 30. So entire paths are same. Here also 30 and here also 30. So it will be moved to the AD value. In between, whichever having the AD value is lowest AD value. Here it will be check the lowest value. In between, we have the AD value is 1. Static, here we are using static AD value is 1. And EAGRP AD value is 90. And RIP AD value is 120. So it will be elect lowest AD value. So lowest AD value is static. So it will be elect static. And it will be if type, here also we are using static, here also we are using static. If you are using RIP, here also RIP, here also you can assume like RIP. Entire RIP 120, 120, 120. Then AD value type. Then it will be moved to the metric. And metric, it means OSPF metric different, EAGRP metric is different, RIP metric is different. RIP metric is hope count. RIP metric is hope count. It will be elect whichever having the less hope. 1, 2, 3, 4. Here 1, 2, 3. Here 1, 2. Here 1, 2, 3. Here 1, 2, and this is a 2. Sorry, this is a 1 and this is a 2 and this is a 3. And this one is the only one. Whichever having the less hope count, it will be elect based on that. And OSPF, EAGRP will discuss later. But here it will be first one and second one and third one. It will be moved to the metric value. If metric also match, then it will be moved to the ECMP, equal cost multipath. Based on that, it's a load format, equal cost multipath. Based on that, it will be select. Here we have a for how it will be router will elect the best path. Base criteria is there, that is like longest prefix, AD value, metric, ECMP. You should have to know these four things. Any doubts in that? I hope AD values also you can you have understood.
Yes, sir.
And how we'll configure? Just write these commands in static. How we are configuring configuration part. This is the configuration part. Syntax I'm giving here. First move to the IP route, then whichever the destination and destination subnet mask and next hop IP address. Two ways we can configure it. First, we should have to know the destination IP address, destination network, and destination subnet mask. Then we should have to know the next hop IP address. What is next hop IP address means? This is R1 and this one R2. This is your LAN network. One is LAN and this is your another LAN. So we are configuring here this network. This is our 192.168 something. 160 or something here 10.1 something. So we should have to know destination. So this is a destination IP address and this subnet mask, destination subnet mask. Again, this is the next hop IP address. Next hop IP address. Otherwise, exit interface also. This is the exit interface we should have to know. And otherwise, we know the next hop. This is the next hop. Here, this one is yours destination IP address and this one is your destination subnet mask, whichever the subnet mask. Apart from that, next hop IP address is this one. And if you can configure first way and second way, two methods we can configure. If you know the exit interface also, it is fine. Whichever exit interface we should have to know. This is a configuration.
Is it similar to that lab that you explained the day before yesterday?
Akhil, what you said, I am not getting.
Like you have said this one, right, sir? IP route, destination ID, subnet mask, and pop IP address.
Wait,
You
wait,
have
wait.
done this in like day before yesterday lab.
Akhil again.
No, I'm what I'm saying, like it is similar to what we have done in day before yesterday's lab. Like IP route, we have configured like ISP and ISP.
Headphones issue. Never thought of it. Guys, I am facing issue everyone now. When Akhil is speaking. Hello.
I'm
We
hearing
can
you.
hear we can hear
Sorry.
you and Akhil as well.
No, Akhil, tell me.
Yeah, like in like day before yesterday lab, you have discussed right in ISP. We have we have given this command already. That's what I'm saying. Is it the same
Yes,
command?
yes, yes, yes.
Yeah,
What we discussed
that's what I
yesterday.
want to. Yeah.
Sorry, my headphones issue.
Okay. Okay.
Fine. So yesterday, what we discussed for that only. Now move to the. Here some advantages we have in whenever we are configuring the static routing. Advantage we have. So there is no overhead on the CPU because whenever we are configuring the destination IP address, so that is the reason. So where the CPU utilization also very less, and there is no bandwidth usage between routers. Yeah, whenever we are using the source and destination, so we are only informing this is your destination, this is your source. So here also no usage of much more bandwidth. It adds security because the administrator can choose to allow routing access to certain networks only. So we are configuring. So there is more secure. It's a more secure. That is the reason that is a more secure. And some disadvantages also we have. So used for the small network, for it is not for the long networks, only for the small networks we can use. Each and every network has to be manually configured, and each and every network we have to configure manually. So administrator understand and internetwork and how each router is connected in order to configure routing correctly. Means everything administrator should have to know entire the routing information, entire each and every interface, exit and whichever exit interface and next hop IP address and destination hop IP address, entire routing administrator should have to know. Any changes in the network has to be update in all router. If any update is occurred here, so we should have to change entire routing tables. Entire routing table we should have to update. So some disadvantages also is there, but here mainly security part it is okay. Some government organizations will use the static one, and but in real time will use dynamically configured. And dynamic, whenever you are using, this is all about the static routing. Any doubts in static?
No, sir.
Okay. So now move to the default routing. And default also we should have to configure statically. Means here not overhead. Whenever you don't know the destination IP address also, just with the help of 000 command, we can configure it easily. So I'll give you a brief introduction about it. So default route is used when destination is unknown. It is where we'll use this internet. In internet, we don't know the destination IP address, so that time we'll use. Also can be used at end location where there is only one exit path for any destination. And when we'll use, actually, this is your LAN location. You can assume this is your LAN location, entire LAN, and this is our WAN location. And at WAN location, you have multiple path. So this kind of path you have. And this path where it will be connected basically at one another end. So we don't know entire thing. There will configure default, otherwise will configure dynamic routing. When we don't know the destination IP address, where we don't know the any IP destination network and all, when configure it. Default route help in reducing the size of routing table. Yes, what we are doing, only we are configuring 0.0.0.0 and subnet mask also 0.0.0 and next hop IP address just we are giving here. Just we are giving the destination hop IP address. if the router do not found entry for destination network in a routing table, the router will forward the packets to its default route. What does it mean default route? 0.0.0 only. 0.0.0 and 0.0.0 and next hope exit or next hope IP address or exit interface. It will be forward to 0.0.0. It means entire networks available. Slash value 32. We have a 1 billion more than that IPv4. IPv4, how many IP addresses are there? It will be traffic will be forward through this IP address. It is available in this entire IPv4, you can assume. When we don't know the destination IP address, it will be forward based on this. That is default routing. Where we'll use mainly in internet. Internet means this is your provider edge router and this is your customer edge router. CE, customer edge and provider edge. This is a WAN between. So we'll configure for this interface as a default routing. And we'll give this is the next hop IP address, whichever the public IP address, whichever public IP address will configure likewise. Just this is your customer edge means our router, our branch router. This is our branch router. This is our ISP router. ISP router. In between will configure likewise. Where so it will be entire world we can access. This is your LAN location connected one PC. Sorry, one switch. This is your switch and switch is connected to your PC and your PC, one more PC. End users. So these are our end users. They can access likewise. But whenever you don't know the destination, that time we'll configure the likewise. And entire routing, less routing table. It will be in routing table. It will be very short here in default routing. Any doubts in default routing? And move to the some advantages and disadvantages for this. There is no there is no need to know destination IP address. Need advertise the directly connected network. Updates the topology changes dynamically. Administrative work is reduced and administrative work whichever network engineer are there the work is very less used for the large organization, not for the small organization. A neighbor router exchange routing information and build the routing table automatically. They'll automatically build the routing table. This is easier than using starting and default routing. This is a easy. Just we are configuring 0.0.0 and subnet mask 0.0.0. I'll show you in that lab once we'll finish. And types of dynamic routing protocols we'll discuss now. Types of dynamic routing protocols. These are the advantages. Any doubts up to here?
No.
So types of dynamic routing protocols, actually we have distance vector protocol, link state protocol, and hybrid protocol. And so here dynamic routing protocols, like first one is IGP and EGP, interior gateway protocol. IGP, interior gateway protocol, where we'll use mainly within an organization. It means at LAN location we'll use. This is one LAN and this is one another LAN. And this one is a WAN. So within an organization, you can assume this is your switch and switch. This is a distribution switch and this is a core. And this one is connected to access. And this one is distribution. Again, distribution is connected to access. Distribution and access. And these are the your end users. So in between we will configure trunk port. Trunk will advertise multiple networks, right? Here we'll advertise multiple network 24 and 1.24, 2.24, 3.24, 3/24. And here we have a different networks here. So in between, this is a your IGP. We'll use IGP protocols. And in between, at LAN under LAN, at LAN location, we'll use IGP protocols. And in between, two different location, two different branches, two different locations, and two different organizations, two different ISPs, two different internet service providers, anything, two different. Like Wipro to IBM, IBM to some Tech Mahindra, likewise, two different organizations will use EGP protocols, and interior inside will use IGP protocols. In these IGP protocols, we have OSPF, RIP, EAGRP, and ISIS. But exterior protocol, that is only one protocol, that is BGP protocol. These all are interior gateway protocols and exterior gateway protocols. At WAN location, we'll use EGP. At LAN location, we'll use IGP in simple words. In a simple words. Understood?
Yes, sir.
Guys,
Yeah.
fine. So this is about, we'll discuss now RIP protocol. Here we have a distance vector routing protocol, link state routing protocol, and path vector routing protocol. Here in distance vector routing protocol means it will be work hop by hop. And link state means it will be having entire link information. Here we have hop by hop information, but here we have the entire links information. We'll discuss later on sessions, but here hop by hop it will be work. That is RIP protocol. So now we'll discuss here routing information protocol, that is RIP. RIP stands for routing information protocol. RIP. There we have two versions, version 1 and version 2. We have two versions in RIP, but RIP stands for routing information protocol. And it is a open standard protocol. RIP is a open standard protocol, means it will be work entire, means Cisco devices also and non-Cisco devices also. Non-Cisco means HP, Aruba, those devices it will be work entire. All the devices it will be work RIP. And it is a class-full routing protocol. It is a class-full routing protocol. What does that mean? We have a classless and class-full routing protocols. And class-full routing protocols will carry only the subnet mask, whichever full it is there. It's a class A and class B and class C. What does it mean? Full subnet masks. Slash value 255.255.255.0. It's a class A. So class C, and before that 0.0.0 is a class A, like 255.255.255.0, class B, and 255.255.255.0. It means it's a slash 8 value, and this is a slash 16 value. Slash 24. It will be carry this route. RIP will carry likewise. If the class full is there, then only it will be carry. If class less means slash 25 slash 26 slash 27. Likewise, if it is there, it won't carry this kind of information. So whenever we are configuring subnetting, whenever we are configuring with subnetting, so RIP will not work at version 1, but in version 2 it will be work. I hope got it. What does it mean, classless and class full? Class full, it means class full protocols, like it we do not carry the subnet mask. Just I have mentioned here, it will not carry the subnet mask. Now move to the classless, it will be carry with subnet mask. Classful protocol, classful routing protocol do not carry the subnet mask information along with update, which means that all devices is not network must use the same subnet mask, that what we discussed earlier, FLSM, VLSM, those things. But here will it will work like legacy protocols. This is RIP version 1 and RIP version 2. Now RIP version 2 will work classful also. We need whichever the entire it will be carry the with subnet mask, that only we need. So we'll use mostly these protocols only. OSPF likewise nowadays. it will be carry with subnet mask. And it will be support FLSM, VLSM. So here if the slash value like 25 and slash value 26, slash value 27, if it is there, so it won't carry. If version 2 is there, it will be carry. And OSPF, EAGRP and ISIS, this protocol will work like classless routing protocols, classless routing protocol. Only RIP version is classful routing protocol. Some interviewers ask this question: what is the difference between classless and classful? And RIP sends update broadcast via 255.255.255.255. Whichever the updates are there, whichever the messages, updates, any update, if neighborship went down, any happen, it will be send update through broadcast information. Means this is also problem. Switch what it will be do? Broadcast the information. Whichever the updates are there, it will be sent to entire interfaces. So likewise, here the RIP also, it will be sent how many paths are there, how many routes are there. It will be sent entire updates to entire network, entire paths. How many paths available in that router, it will be sent to entire network, entire paths. It's also problem. Updates will send via broadcast IP address. And AD value we discuss, that is 120. RIP having the AD value 120. And then we'll discuss what is the metric. Now router will work based on the, it will be elect based on the path, that is metric, that is hope count. Whichever the least hope, that is the best one. Whichever having the least hope, that one is the best one. And maximum hopes are here 15. Maximum hopes are here 15. And it will be up to say it will be not, if 16th path it is there, it will be not send the information. If it will be sent up to 15 only, it will calculate like for example, this is your source and your destination. In between, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the 16th path. Then it won't send 16th path, the information. If we have up to 15th path, 15 routers only, this is the 15th one, it won't send. If it is 14th one, then it will be 15th one, last one is 15th one. Up to 15th router, it will be work. And whichever having less hopes, if there is you are having 14 and in between you are having 1, 2, 3, 4, 5, 6, in between 6, then whichever the less hopes are there, that is the best hope. Even though this link is 10 gig and this link is 1 gig. In OSPF, EAGRP, they'll calculate based on the bandwidth. But in RIP protocol, whichever having the less band, whichever less hope counts, 1, 2, 3, 4, 5, 6, whichever having the less hope, it will be calculated that only. Even though there is, if you are using 100 Mbps, 100 Gbps link also, 100 gig link also, it won't bother about that. It won't carry. It won't take care about that. It won't think about it. It is a bandwidth is more. Even though if you have one path here, this link is 1 kbps. Kbps is very less compared to Gbps. It will be send the information through this link because it will be elect based on the hop count. But in EIGRP, in OSPF, they will be elect based on the bandwidth, that is metric. It will be calculate metric. This is the metric. We'll discuss OSPF and EIGRP, but in RIP protocol, that is the overcome. That is the defect. That is a disadvantage. It will be select based on the hop count. Even though that is 1 kbps also link. And as I mentioned, here we can write here the 16th path is unreachable. If 16th path is there, that is unreachable. The packets will be dropped. Here, if it is a 16th packet, the packets will be dropped. And here it will be load balancing the information up to 4 equal cost. For equal path up to, it will be load balance the information. Mean first path, second path, and third path, and if we have another path likewise. First path is this one, and second path is this one, third path is this one, and fourth path is this one. If first path is down, then it will be select second path. If second path also down, it will be move to the third path. And will load balance also it. Same thing. And the RIP protocol will not use for the large organization. It is suitable for the small organization because see, you can assume like only 15th hope it is working. So we'll use this protocol as a small organizations. It is not suitable for the big organizations. It is for the small organization we'll use for this RIP protocol. And it will be send, one more thing, it will be send update every 30 seconds. And whichever the routing table went down, any routing updates it happen, this routing, see, every 30 seconds, this is your path. Every 30 seconds through, every 30 seconds, the routing update will be sent. Periodically, it will be sent. Every 30 seconds, this router R1 to R2, every 30 second periodically routing updates, it will be sent every 30 seconds. If any changes occur, that time also it will be sent. If any changes occur, that time it is sending is okay, we can assume. But every 30 seconds it is no changes, nothing it is there, then there is sending some update means that is issue only. But it means you can assume he's like this routing is sending every 30 seconds. No updates are there. The link is working fine. This link is working fine till every 30 seconds he's knocking. Hi, 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 hello, 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 hello. Every 30 second he's knocking his door. Then that is a problem only. He's a neighbor. He's knocking every 30 seconds. Hi, how are you? Hi, how are you? He's knocking likewise. If some problem is there, he's knocking his door means okay, that is valuable. But no problem is there. Again, he's knocking his door. That is issue only. So every 30 second periodically exchange routing information, routing table, entire routing table, they are exchanging. Whenever they're sending the hello packets in every 30 seconds, in that what they're sending entire routing table, So the CPU utilization is more whenever we are using RIP protocol. So in one words, routing RIP protocol as a network engineer, we should have to know, but in real time, we are not using this RIP protocol. We are using mostly OSPF and EAGRP. OSPF and EAGRP. Apart from that, this ISIS are intermediate system, they are using mostly ISP, Internet Service Provider, they are using this protocol. But 80% organizations are using this, and Cisco, it's a Cisco proprietary. So you mean to say 20% of organization using nowadays. This is all about RIP protocol. If you have any questions, ask me. We'll move to the lab. We'll configure the lab.
What is the difference between version 1 and 2, sir?
If you have any questions, ask me. Otherwise, we'll start lab.